So today we are going to be skipping 3.4 and doing that on Friday. What we're going to be doing today is factoring trinomials again, but this time there's going to be a leading coefficient. So before we looked at trinomials that looked like, say, x squared plus 3x plus 2, and then we were able to use the diamond method on that. Find two numbers that multiply to 2 and add up to 3. In this case, it would be 2 and 1. And then we factored that out to x plus 2 times x plus 1. All of the trinomials that we factored looked like this. It had just an x squared in front of it, unless we could factor out a GCF. Today, there's going to be a number in front of the x squared that we won't necessarily be able to factor out a GCF. So when we are factoring something that looks like ax squared plus bx plus c, it's going to factor out to have some number in front of each of the x's after we break it up into two sets of parentheses. So what we're going to be doing is having to fill in all of those blanks. There is a method for doing this. It's called the bottoms up method. It's also been called before the over-under method. So here are the steps. There are 7 steps here to the bottoms up or over-under method. Okay, step 1, you need to factor out a GCF if possible. This is very important because if there is a GCF in the trinomial and you don't factor it out, the entire method will not work and you will get an answer that does not make sense. So you should always check for a GCF first. After you check for a GCF and factor it out, if there's still a number in front of the x squared, you're going to multiply the very first and the very last term. So you're going to multiply the first two terms together, or the first and last term together, and you're going to take that product to create a brand new trinomial. Okay, so you're going to create a brand new trinomial from multiplying the first and third terms. After that, your new trinomial is not going to have a number in front of the x squared. So you're going to be able to factor that using the diamond method. So you're going to want to factor your new trinomial using the diamond method. After that, you will be able to divide each number in parentheses by the first term. It's another typo. The first term in the original problem. So you're going to take the first term from the original problem and divide the numbers in the parentheses by that term. That's going to give you a fraction that you want to reduce if possible. Okay, so you're going to reduce the fraction if possible, and then whatever's left in the denominator, you are going to move up to the front of the parentheses, and that is the bottoms up. Okay, so that's where we get the term bottoms up. So let's look at our first example. Example 1. I have 2x squared plus 7x plus 3. Now the first thing I want to look for here is a GCF. There is not a GCF in here. We have a 2, a 7, and a 3, so we can't do that. So that was step 1. I'm going to go on to step 2, multiply the first and the last term. So I take that first term and I multiply it by the last term. So 2 times 3, and that's going to give me 6. So step 3, write a new trinomial. If I take that first term and move it to the last term, that's going to give me x squared plus 7x plus 2 times 3, which gives me 6. So I have a brand new trinomial, and this time there's nothing in front of the x squared. So I can factor this guy using the diamond method. So using the diamond method, I'm looking for two numbers that multiply to 6 and add up to positive 7. And that's going to be positive 6 and positive 1. So to factor that, I'm going to get x plus 6 times x plus 1. Okay. So that was step 3 to create a new trinomial. Step 4 was to factor that trinomial. And then step 5 is divide each number in parentheses by the first term in the original problem. My first term was 2. So I'm going to divide each of the numbers by 2. So that's what it means to divide each number by the first term. I take that 2 that I multiplied, and since I multiplied it, now I have to divide it back out to undo what I did. So then I'm going to reduce any fractions if possible. Let's look at 6 over 2. That does reduce. 2 goes into 6 3 times. 1 and 2 does not reduce, so we're done with that step. That was step 6. Finally, step 7 is to move the bottom number up. There is no bottom number left over anymore. It's a 1 right now, and that doesn't change anything. But there is this 2, and we're going to move it up in front of the x, and that's your bottoms up. So let's rewrite our answer. The first binomial is x plus 3, because the 6 and the 2 reduced. And then the second, that 2 comes forward in front of the x, so we get 2x plus 1. So now we moved that 2 in front of the x to leave us with just the 1. And that is completely factored and the bottoms up method. Okay, let's try it again with another example. So example number 2. We have 6x squared minus 17x plus 5. First thing I want to look for is a GCF, but I don't see one. So I'm going to take the first and the third term and multiply them. So that's going to give me x squared minus 17x plus 6 times 5, which gives me 30. So then I can factor that using the diamond method. I'm looking for two numbers that multiply to 30 and add up to negative 17. So since they multiply to a positive but add up to a negative, I'm thinking both numbers have to be negative. And that's going to be negative 15 and negative 2. So to factor that, I'm going to get x minus 15 times x minus 2. So that's this guy factored. Now we're not done because in the beginning of the problem we multiplied 6 times 5. So we have to divide everything by 6 in order to undo what we did at the beginning. Let's look at the fractions and see if we can reduce. 15 over 6. That doesn't reduce all the way, but 3 does go into both 15 and 6. 3 goes into 15 5 times, and 3 goes into 6 twice. Now let's look at 2 and 6. 2 goes into 2 once, and 2 goes into 6 3 times. So then I take the bottoms and bring them up, and that's going to leave me with 2x minus 5, because that 15 reduced down, times 3x minus 1. And that is your completely factored trinomial with the leading coefficient. Example number 3. So example number 3, we have 2x squared plus 4x minus 6. Now if I look here, I do have a GCF in this problem. So let's factor out that GCF. The GCF was 2. So then that's going to leave me with x squared plus 2x minus 3. Now this x squared is by itself now, and we don't have a leading coefficient. So we can just use the diamond method here. So I'm going to look for two numbers that multiply to negative 3 and add up to positive 2. That's going to be negative 3 and positive 1. So I need to bring the 2 down because the GCF doesn't go anywhere. And this whole trinomial factors to x minus 3 times x plus 1. That is fully factored all the way. So that is my answer. So it's very important to look for a GCF first for one of two reasons. First, it might make your problem a lot simpler, so we don't have to actually go through the entire bottoms-up process. Second, if you use the bottoms-up without pulling out the GCF, you'll get a different answer than what you would get if you factored out the GCF because of the way everything reduces. So it's very important to always look for a GCF first. So example number 4, we have 4x squared plus 11x plus 7. Looking at my trinomial, I don't see a GCF, so I'm going to go straight into bottoms up. So I take that 4 and multiply it by the 7, which is going to give me x squared plus 11x plus 28. I can use the diamond method on this. I'm looking for two numbers that multiply to positive 28 and add up to positive 11. That's going to be 4 and 7. So this factors to x plus 4 times x plus 7. Now I'm not done. A lot of times students want to stop here because it's factored and they think they're done. If we were to FOIL or use the box method on what we have left, x times x gives me x squared, but my original problem was 4x squared. So I need to multiply both sides by that 4 so that I can complete the bottoms up method. 4 and 4 reduces to 1 and 1, and 7 and 4 does not reduce. So we take what was left on the bottom and bring it up. So I am left with x plus 1 times 4x plus 7. And it does not matter if you put the 4x plus 7 in front of the x plus 1. Whichever way you want to order them is fine. The important thing is to make sure 4x plus 7 is together and the x plus 1 is together in parentheses. But the order of the parentheses does not make a difference. So our last problem, example 5, says a rectangular prism is shown below. The volume of the prism is 8x squared plus 20x plus 12 cubic units. If AE, that's this part right here, is 4 units, find the area of the base. Well, let's think about it. They're telling us in the problem what the volume is. Now, the formula for volume is length times width times height. This EA, the 4, is my height. So they're giving me the height. Now, part A asks for the area of the base. The formula for area is length times width. Now notice, length times width, that's already part of the volume formula. So another way that I could write the volume formula is area times height. And we know what the height is. So for part A, when they're asking us just to find the area, we know what the volume is. Since volume is length times width times height, and we know what the volume is, 8x squared plus 20x plus 12. We know we need to find the area, but it's also being multiplied by the height, which is 4. So volume, which is length times width times height, or area times height, is equal to 8x squared plus 20x plus 12, and that's the area times the height, which is 4. So to find the area, or to get the area by itself, I can divide both sides by 4. 4 and 4 reduces to 1, so that's going to leave me with the area by itself. And when I'm dividing the entire left-hand side by 4, I have to make sure that I'm dividing every single term by 4. So 8 divided by 4 is going to give me 2x squared. 20x divided by 4 is going to be plus 5x. And then 12 divided by 4 is going to be plus 3. So that is the area of the entire base. Now part B wants me to find possible lengths for AB, which is the width, and BC, which is the length. So basically they want us to find what two things could the area or the length and width be equal
Justin
to.
Barnett, please report to the Rayburn main office.
So we want to actually factor what our area is. So I have 2x squared plus 5x plus 3, that's my area. and they just want us to factor this. So let's look for a GCF first. There's no GCF in here, so I'm going to use the bottoms up method. So 2 times 3 is going to give me a new trinomial of x squared plus 5x plus 6. And then we can factor that using the diamond method. Two numbers that multiply to 6 and add up to 5 are 6 and 1. Or, I'm sorry, 2 and 3. So that's going to give me x plus 2 times x plus 3. And then we have to divide both by 2 because that was our original first number. So 2 and 2 reduce to 1. 3 and 2 don't reduce at all. So bringing that bottom up, the two possible widths are x plus 1 and 2x plus 3. We don't know which one is which, but we do know one has to be the width and one has to be the length. So we're going to leave it as our factored form, x plus 1 times 2x plus 3. And that is the bottoms up method for whenever you have a number in front of the x squared.